Hello everyone and welcome back. This lesson number 4, we will cover more details about forces and equilibrium in a plane, and mainly at a point, because later we're going to go to 2D structure and so on. So it means that all the forces are acting at a single point, okay, in a plane right now. So let's move to the tutorial and find out how we're gonna do that in this video. Okay, so now for equilibrium or forces acting on a plane at a certain point, let's identify first what is equilibrium of a particle. So if at certain particle, if there is an equilibrium, it means that all the summation of the forces acting at this location or at this particle should be equal to 0. So the vector, all the summation of the vector at this location is equal to 0. Means that if I draw the force polygon, we should get 0. You start from a point, you go to the end by the same point. We'll explain how we're going to do that, and then also we can apply that by using what? By components. So either we're going to do by the constructing the polygon or using the analytical solution by using component. So let's see what we have. If I have two forces, we know that for equilibrium this is an easy case. For equilibrium, the two forces has to be equal in magnitude and opposite in the sense. Means that if a force going up with a 50 pound, another force should be going down with a 50 pound to maintain the equilibrium. You can't have equilibrium for one force unless the force is 0. Okay, but anyway, so for two forces, you're going to have this. This is easy. The two forces equal in magnitude but opposite in the direction. But if I have more than two forces, whatever the forces are, and then I want to draw the polygon of these forces. So what you're going to do is I'm going to start one by one and just add them. And if at the end, if I start from a certain point, it come back to the same point, it means the summation of all the forces, as you can see here, are equal to 0 because I came to the same point. For example, if I have F1, so here is the point O. At point O I have F1, and then I'm going to add F2, and then I'm going to add F3, make it 30, and then I'm going to add F4. So this means that I started from the point O, I moved with the forces vectorially, and I went back to the same point I start from with 0 value at the end. Means that these forces are in equilibrium and they satisfy the condition of equilibrium. Now let's see how we're going to adopt the solution method and so on. So to adopt the solution method, first thing we need to do is to draw something called as a free body diagram. This is a must, okay, in a way that, because this will help you to identify the problem accurately. So drawing a clear and accurate free body diagram is a must in the solution of any equilibrium problem. Let's look for this one here. This is like the problem itself. We say, okay, I have a load, I'm going to carry it or put it on a truck and so on. But this is called what? This is called a space diagram. So the problem itself is called the space diagram. Now, to draw the free body diagram of this, we're going to concentrate in a certain point. And the point which has all the forces acting on, or the point of interest, should be point A. So now I'm going to click and get point A. So I start from point A and start putting the forces acting at point A. So what I have acting at point A, I have the weight. So I have the weight here acting at point A. And then I have a tension from this rope. So I have a tension going this direction, and I have another tension going 55 degrees with the horizontal. So this is the third force. So now I have three forces, the acting at point A, and these are the forces acting at point A. So this diagram here is called what? It's called the free body diagram. You choose the point of interest and you label or you put the forces acting at this point, okay? Now we need to move to the next step, which is after you draw the free body diagram, you're going to say what is the methodology of solution. So there are two types of problems we would like to identify. mainly as the first case solving problem, the case 1, when I have only 3 forces. So if I have 3 forces, or I have more than 3 forces, okay? So now, when a particle is in equilibrium under 3 forces, you can solve the problem by drawing a force triangle. So what you're going to do, we're going to do triangle of forces or force triangle. We're going to draw the triangle and solve it trigonometrically. So it's better to do it with the force triangle if I have only 3 forces, okay? Like what? Let me see what we can have. Suppose I have these 3 forces, like this one here, which is the problem of the truck again. So I have this force going down 750. The other tension here is going 30 degrees with the horizontal in the east direction, and the other one here, the tension AB, is making 55 degrees with the horizontal but going to the west direction. So now this is what called, this is the free body diagram. So from the free body diagram, I'm going to start drawing what? The triangle of forces, okay? So now to get the triangle of forces, what I'm going to do, I'm going to first, the step number 1, you start with the known forces. I know only one force, so I'm going to start with this force. So I'm going to say, okay, I have the force 750 vertical. So I have the force 750 vertical. And then I know this one direction and magnitude. So I know the beginning and I know the end. So from one end, you're going to draw the second force. I know this direction, but I don't know the magnitude. So I'm going to say, let me draw a line in the 30 degrees. So this means I got the line direction here. This is just a line direction here. And then you go to the other tip from the other end here. You draw a line in the same direction of TAB. So if you do that, you draw a line making what? 55, so it's going to be 35, I believe. Yeah, so it's going to be 35 with the vertical. So you draw a line parallel to this one here. So when you're going to meet here at this point, so this one go 30 degrees. And this one 35 with the vertical, so they're going to meet at a point. So this determine the end of each one, to the end of this one, and determine the beginning of this one. And so this way I can calculate the value or the magnitude of both of them accurately. So this way I draw what? The triangle of forces. After you draw the triangle of forces, you will adopt what? The method about the triangle of forces. You will adopt either, you look at the situation you have, and we covered that on lesson number 2, where you have a triangle of forces, and you say, okay, when I should use the sine law or I should use the cosine law, this will give you the solution, and you'll get very accurate solution based on you have only what? 3 forces meeting at a single point. Now suppose you have the second case. So in the second case, I have more than 3 forces. So if I have more than 3 forces, there are 2 ways of solving this problem. First, I can do it graphically by drawing the force polygon, or I can do it analytically by using what? The equation of equilibrium. So let's start first the graphical solution, or graphically by drawing the force polygon. So now first I'm going to start with what? The free body diagram, okay? So suppose this is a free body diagram, means that I was able to get the point of interest A, and what are the forces acting at this point of interest. I have force P 60 pound down, I have a force Q horizontally, I have a tension TAC making 30 degrees with the vertical, and another tension making what? 30 degrees with the horizontal, and it is 50 pounds. Okay, now so I need to determine what is the tension here, AC, and what is the value of Q. So this is now the free body diagram, because it locates all the forces coming from acting on one point. Now the next step is what? To draw the force polygon. I'm going to draw this is the graphical solution, the first solution. So now we're going to say, okay, I'm going to start with the forces we know. So I'm going to click get the forces we know. So now I start with the first, this is the beginning point. I'm going to say O. So I'm going to go down with 60 pounds of this one here. Then I'm going to add to it the 50, making 30 degrees. So we're going to say, okay, from the tip here, I'm going to add what? The 50, the tension AB at 30 degrees. So now I start from O. I start building the forces, the vectors, And then the next step is what? To add what? TAC. So I know the direction TAC, but I don't know where it should stop. So what I'm going to do is just, I'm going to draw a line TAC making 30 degrees with the vertical just as extended all the way. But it will stop when you have the force Q, which is horizontal, means that it's going to go to O. So means that I'm going to draw a horizontal line here, and I draw a line 30 degrees with the vertical. When they meet, they will constitute the end of the first one, the TAC, and the beginning of Q. And once I solve this graphically, and I measure the length here, TAC, and the length of Q, I determine the magnitude of TAC and Q accurately, or based on the dimension or the measured dimension. This is graphically, okay? Now the next solution is do it analytically, which is I recommend. So now we recommend, if you have 3 forces, you use the triangle of forces, and for more than 3 forces, it's better to use what? The analytical solution, which I will cover it in the next slide. So now suppose that, okay, I'm going to do the same problem. I'm going to solve it by equilibrium, equation of equilibrium. So what we have here, okay, I have the free body diagram. I'm going to start from the same free body diagram because I'm solving the same problem. And then I'm going to see how the rectangle of component will act. So for the free body diagram, I have these forces, as I mentioned before in the previous slide. I have 60, I have 50, and I have this angle 30 and the angle 30 here, and this one is horizontal. So the next step is what? Is to get the point. Okay, at the point A. Okay, I'm going to say from point A. What I'm going to resolve this component into two X and Y. So for Q, it is the same Q. So it's going to X the component. It doesn't have Y component, so we're going to have Q. Now for the other force here, P, which is 60 down, it is in the Y direction, so it doesn't have X component. So I'm going to add another X. So now so far I have to go. Now the force TAB, the tension in rope AB, it has 50. Now it has 2 components because it has 30 with the horizontal. The 30, since the 30 with the x-axis means that the component in the x-axis is going to be what? In the negative direction, it's going to be 50 multiplied by cosine, and the vertical one will going to be what? 50 multiplied by sine. So now I got 2 components, one negative and one positive. So let's get the 2 components of TAB, the 50. Okay, so I have 2 components here. So sine 30 is half, so half of 50 is 25, and this is cosine of 30 multiplied by 50. I get this value. So I got the 2 components of what? Of the tension in AB. Now let's get the 2 components of the tension at AC. So I have again 2 components. In the x direction I have sine 30, and in the y direction I have what? Cosine 30. So now we're going to have this. Why I have it as cosine 30 with the y direction? Because the angle between the y direction and the force. So now I have TAC cosine and TAC sine. So now by solving this set, what adoption I should use? I should use sigma forces in x equal to 0 and sigma forces in y equal to 0. So I'm going to add the forces in x and all the forces in y and equate them to 0. So if you look here in this problem here, I will start with the one that have only minimum unknown. So I'm going to start with the equation of sigma forces in y equal to 0. So this way I can calculate TAC. So if you have here, you have 60 down, minus 60, plus 25, plus TAC cosine 30 equal to 0. From this one, you calculated the TAC and you get the TAC is what? 40.4. Now by sigma forces in x direction, what I have minus 43.3 plus Q plus TAC sine 30. I got TAC already, so I get just TAC multiplied by sine 30. I solve the equation and I find what is the value of Q. Since the value of Q came positive and the other one came positive, means that my assumption of the direction are correct, and we got the answer of the solution of more than 3 forces. And this should be the adopted methodology. To strengthen what I just covered so far, so what we're going to do is we're going to solve problems, examples, to demonstrate the concept I just covered. Now let's implement these rules by using 2 examples. The first example I have is I have 2 cable CA and CB. They are tied together here at the point C, and there is a force P, 550 Newton, and making an angle 75 degrees with the horizontal. So actually what I have a force P making an angle 75. I have a tension in the cable CB making 30 degrees with the horizontal, and another tension CA making a 45 degrees with the horizontal. But the two values of the TCB and TCA are not unknown, are unknowns. Now we would like to calculate what is the tension in CA and tension CB in the two cables. So now let's practice what we learned. What we get, the first step, what we're going to do, we're going to start drawing the free body diagram. Now this is the space diagram, which is tell you what is the problem. Now we're going to draw the free body diagram, and to draw the free body diagram we're going to concentrate where is the point of interest. I see that the point of interest is point C, where all the forces are acting at point C. So what I'm going to do first to draw the free body diagram is I'm going to say, okay, here is point C, and at this point I have a force which is 550, making an angle with the horizontal 75 degrees. What else? This is X and this is Y. Okay. Now the next force is what? Let me do it in red. So I have this force. Then the next force I have is the force, the tension in the cable CB. So I have this tension in the cable CB. And is making 30 degrees. And this is a tension CB. And then I have another tension making 45 degrees. So in this direction, we call it tension TCA. And is making 45 degrees with the horizontal. So now this is my free body diagram. So I was able to draw the free body diagram showing the three forces, how they behave and how they affect the point C. So this is point C. Now the next step is, since I have three forces, we said that the best way to approach if I solve for three forces is to use what? The triangle of forces. We're going to solve it using trigonometry. So now we need to draw the triangle of forces. So the first step is to draw the, okay, so now the first step is to draw, okay, the first, when I draw triangle of forces, first I start with the force I know. So what I'm going to do, I'm going to say, okay, I have this force, which is 550, and is making with the horizontal 75 degrees. 75 means the same thing here with the horizontal here, 75. Okay, now the next step is I know the beginning and the end of this force. So here is the beginning, and here is the beginning, and here is the end. So choose from one of the, I'm going to choose from the end. I'm going to draw what? The next force, which is TCB. So I'm going to move what? Draw a 30 degrees with the horizontal. So this will be the direction of this force. So I know the direction, but I don't know the magnitude. So I'm going to just make it as a direction. And to come from the other end, from the beginning of this one here, I'm going to draw what? A parallel line or a direction of making 45 degrees with the horizontal. So it means that if I have a horizontal 45 here, so I'm going to draw a line this way, and then it's going to meet with the other one here at this point. And when they meet, automatically I need to make what? A closed loop. Means if I start from here and I go down, then from here I'm going to go up to this point, and then after that I go up to this point. And this is becomes what? The triangle of forces. So now we don't need, I can leave them, just I don't need these and this one. Okay. Now let's put the angles. So I know the value here 550 Newton. Okay. Newton. Now the angle here, the total angle is 75. And this angle here is 30, so it brings me that this angle will be how much? 75 minus 30 is going to be what? 45. If I know, okay, now look at, find this angle here. So this angle here is what? The whole angle here is 180. I have 75 and another 45. So if I subtract that from 180, so 75 plus 45 is 120. I'll subtract from 180, so this will be what? 60. So 180 minus 120 is going to be 60. Now let's get this angle. It's going to be the summation of all the angle of the triangle should be what? 180. So this way, or you can get it from what? From making a horizontal line. I know this angle is 45 and this angle is what? 30. So 45 plus 30 is what? Is 75. So I'm going to say this is 75. Okay, so I got all the three angles and this is a triangle of forces. Now let's adopt the solution. What is the solution for this case? We say, okay, I have one side and I know all the angles of the triangle. So this is a case of what? Since I am given one side of the triangle of forces and I know all the angle, means what? I have to start my solution using what? The law of sine. This is the rule. Let's go back to the lesson number 2. So now let's apply the law of sine. So what I'm going to say, okay, okay, let's name this one. This is what? TCB. And this one is what? TCA. Okay. So what I have TCA facing the angle 45, or we call it sine alpha, and then TCB facing the angle 60, and then I have the 550 facing the angle 75. So let's put the number here. So here is the number. So I have TCA facing the angle 45, so going to be divided by sine 45, and then TCB divided by the sine TCB facing 60, so it's going to be divided by sine 60, and then the 550, the force 5P is 550 divided by the facing angle, and the facing angle in this case is 75, so I'm going to put 75 here. So now I have two equations now in two unknown. So how are we going to start the solution? Very simple. Okay, I know everything about in this term here, so this is completely I know. Now if I want to solve for TCA, so then I'm going to equate this term here with this term. By doing that, so TCA will be equal to what? I multiply by sine. So if you have this term will be equal to this term. So if I would like to get TCA, it's just all what I need. I use this term multiplied by sine 45. So 550 divided by sine 75 multiplied by sine 45. So I get what? The TCA. Now if I would like to calculate for TCB, so all what I'm going to do is I'm going to use something there. We're going to use what? I'm going to equate the same term, which I have everything here. I know all the values here are known, but this is TCB. If I want to calculate TCBs, then I'm going to equate the red one with the red one. So now to get TCB, I'm going to say, okay, TCB will be what? The 550 is divided by sine 75, and you multiply by sine 60. So I multiply sine 60 to the other side, then you get the TCB. So this way I was able to get both values. Okay, we are able to get the tension in cable CB and the tension in cable CA. This is by adopting what? The methodology we just learned, okay? The second example in this tutorial, we have two cables, AB and BC. They are tied together at B, and they are making an angle 30, both of them make it 30 degrees with the vertical axis, one to the right and one to the left. And we have another force 200 horizontal and another force 280, making 45 degrees with the horizontal. So actually what we have a 200 Newton going to the negative X direction, 280 making 45 degrees with the X-axis, and we have the tension BA and tension BC. We don't know the magnitude, but we know the direction, 30 degrees both. So the first thing is that from this space diagram, we need to start. The first step is what? To draw the free body diagram. Okay, to get the free body diagram, we need to concentrate on a certain point where all the forces are acting. And in this example, we see that point B is the one we need to concentrate on. So at point B, what I have four forces. 280 going down, 200 going to the left, and 2BA and 2BC, they are both going up, making 30 degrees with the vertical axis. To solve the problem, since we have four forces, we said that if you have more than three forces, the best way to do it is to do it by the analytical solution. And mainly as you have to create the components of each force, and then make sigma forces in X equal to 0, and sigma forces in Y should be equal to 0. So now from the free body diagram at point B, so we're going to move to get the X1, Y component. So the first one is the force 280, making 45 degrees with the horizontal. So cosine and sine will give me the two components, since 45 degrees cosine is equal to sine 45. So I have the value here for 280. It becomes two components, 198 and 198. One to positive X and one negative Y. The other force here, 200, is going to the left, so this is one component. Now the TBC is making 30 degrees with the vertical, so we have two components, one in the X direction, which is projection here. So the phase, since the angle 30 with the vertical axis is going to be what? The TBC cosine theta will be the Y component, and TBC sine theta will be the X component. Similarly, we have TBA cosine component will be the Y direction, and the sine component will be the X direction, because this is facing the angle here, or it is between the angle and the Y axis, means the cosine will be in the Y direction. Okay, so we have like how many so far? We have 2 and 2 and 2, so 6 and 1, 7. So 7 components, 4 in the X direction and 3 in the Y direction. And the methodology of solution mainly is going to be in the next step is what? Signal forces in X equal to 0. So here is the 4 forces in the X direction. I have the minus 200 and the minus TBA sine theta, and then plus BC 180, 198, and then TBC sine 30. By solving this equation, we know that sine 30 is equal to 0.5, so means that I have 0.5 TBA and 0.5 TBC, multiply by 2, so to make 1. So then becomes that 200, 198 minus 200 is going to be 2. Move it to the other side, it becomes positive 2, multiplied by 2 becomes 4. So it means that the difference between TBC and TBA is equal to 4. This is your first equation. And we're going to use this equation for what? To solve for TBC and TBA. So this is the first equation, or the first relationship between TBC and TBA. And then the next one is signal forces in Y direction equal to 0. So I have how many? I have 3 forces. TBC cosine 30 and TBA cosine 30, both of them positive, minus 198 going down, negative, equal to 0. So from here I can say, okay, move 190 to the other side, divide by cosine 30, you have TBC plus TBA equal to this number. So I have 2 equations in two unknowns, and these two unknowns are what? TBC and TBA. But it looks like this is TBC minus TBA and TBC plus. So if I add them, TBA will cancel TBA, and this is the first step. By adding the two equations, so TBA and TBA will cancel. I have 2 TBC equal to the summation, and you divide by 2, so you get what? TBC. So I get TBC, the first force. And now let's do by subtracting equation 1 from equation 2. This means that you multiply this one by negative, the first equation by negative, is going to be minus TBC plus TBA. So you add them together, it's going to be the TBC will cancel and they have only TBA. So I have twice TBA will be the summation, which is 232.62. Then divide by 2. Oh, you subtract, sorry, it's going to be subtracted, so it's going to be 224, and this is why when you divide by 2 you get 112.35. so this way we were able to get the second component. I hope you liked the video, and I would like to thank you for watching it, and I would like to hear your feedback. And if you like the video, please subscribe to the channel, click the bell, and give it a thumb up. Have a wonderful day, and see you soon on the next video. Bye bye.